because we're filling in for a seminar, this is going to be a little rough. This is our first time presenting kind of these ideas. John and I have gotten together with Gov Allen and we've taken something that they've done and are trying to do more with it. And I'm going to kind of give an overview of this concept. It's a data analytics kind of a thing. And then John's going to give some examples of what he's actually doing. So we're in the project stage, and then we're going to push this into a dissertation phase a little bit later. So the first thing you need to know is, there's Nick. Nick's one of our people. Come on up here and sit down. There's Gov. I just introduced you to the group in your absenteeism, but these are the two guys that are doing all the great work that we're going to come up here and sit down.
Well, I hope the guys you introduced were better looking.
Yeah. No, we're not worried about that part.
So you're not denying it?
Okay, so this is Nick Ball and Gov Allen. They're the ones that are doing the spreadsheet program that's doing a lot of the things that are producing all the data that we're looking at and trying to use in our efforts with data analytics. The first thing I wanted to point out was that the T in IP&T is for technology. Remember that part? And we do a lot of, my area is interested in how we use technology to improve teaching and learning and how we can make the technology work for us. Now, when I was in University of Alberta, about 25 years ago doing my undergraduate degree, there was this new program called Computing Science. And it just started up, so I got into it, and it was really cool. And they had this system called Plato. We were one of the few universities that had a Plato system at that time. The Plato system was a computer-assisted instruction platform. And basically, it was one of the first efforts to take the pedagogy that we had going on in the classroom and trying to put it into a technology format so that it could make the instruction more effective or more efficient for what we were trying to do. And it was a pretty cool thing. You could go in and, so being an undergraduate student, they used us as guinea pigs. And so I got to go and play on the Plato system. And one of the things that they had was a screen where you could do an experiment and increase the pressure and the temperature on this gas and blow it up or not and things like that. And it was kind of cool. And then they'd ask you some questions about what you learned and whether or not you understood the principles involved. And that was kind of neat for that. That was what we call the computer-assisted instruction platform. So it was using technology to facilitate the instruction, right? And most of the systems that we're looking at now, they do that. They're just taking the instruction that we might do face-to-face and they're trying to utilize technology effectively and efficiently to make that happen better, right? So it's hopefully pedagogically sound and it's efficient in a number of different ways. But what it isn't is it's not intelligent. So at that time, the big buzzword was AI, artificial intelligence. Well, they talked about it making the computer artificially intelligent, but they never really did, and they didn't really know what they were trying to do. They were trying to make it intelligent, but they weren't really, and they never have, and I don't know that they ever will, make it artificial intelligence, where the system actually learns from itself to do whatever it is that it's going to do. So the point that we're trying to do, though, is to make the system intelligent, an intelligent tutoring system, so that it's not just another way of presenting information, but that it actually can adapt and differentiate the instruction for individual learners in some way. That part we've only begun to start developing, and most of them are doing it at a level where, basically at the question level. So you give some instruction, you ask a question, they got it, they didn't get it, you either decide to make them go and learn the stuff again and then try again. So many of the systems that you'll see will say, you know, answer 5 of these questions correctly and you can go on. If you don't get 5, keep trying until you get 5. But it doesn't really try to diagnose any learning problems or knowledge gaps that the individual might have to facilitate overcoming that challenge that the individual has for that. So they can change the pace, the presentation, the remediation in different ways based on information they get back from the user. And that's that data analysis that we're looking at, or in educational terms we call it learning analytics. So in learning analytics, we're trying to use this data to inform our practice. And so we can do this in a number of ways. And Paul and McNeil kind of point out several, but I've picked out 3 that we kind of use most prominently. One of them is to use data to predict best practice. So what leads to success? So we can take a whole bunch of data and say, successful people have done this. It's kind of like the recommender system. You know, so people that have read this book have also done this, this, and this, or read these books. So we say, people who are successful at this have done this, this, and this. And so you design your instruction around that and try to guide them through the scope and the pace of the instruction to formulate a best practice. All of them actually are the second thing where we're trying to improve current courses, right? So we might be improving the way we present, or we might be improving the examples that we give, or we might find that something's not working for them, so we have to improve the examples or whatever it is that we're doing. This last one is really the area that John and I are kind of working at and trying to do is, we're trying to identify learning gaps for individual students as they're learning certain kinds of learning outcomes, or trying to accomplish those learning outcomes, and try to then recommend support or remediation adaptively for the individual as they go through the course, right? So right now, Isis over here has this spreadsheet course, and some of you I know have taken. I know Beck was telling me she was in that course and took this spreadsheet course. And we did a study on flipping the classroom, and we published a paper on it just recently. And students really like this approach. They're more likely to take another course like this one. They're enjoying the course more. That's an important aspect of it. But we want to improve it even more, because at this time, they're producing, what? Lots and lots of data. And it's almost overwhelming, because now I've got this data, what do I do with it? How can I use this data to make my system even better than what it is? And so that's what we're trying to do. So in phase one, how do you make this ITS actually smart or intelligent? You have to understand the problem, and we call this data geology, basically. So this data geology is understanding the formations of the data. What is it actually telling us? What's the likelihood that a formation of data like this gets us into the kind of problems that we're looking at? And then we want to observe what experts might do. So if you had a professional tutor, watching someone go through a task and saying, all right, when I see the student doing these kinds of things, I would try to improve that learning experience by doing this, this, and this. And then the hardest part, probably the part that's going to cause us the most challenge, is establishing protocols. And fortunately, one of the successful things is Gov over here, because he's an excellent programmer. So his job is going to be, once we get this all done, is to actually program the intelligence into it. So once we establish what protocols are, when we see a pattern in the data like this, then what do? We decide this is what you do. And then you have to actually program the computer to recognize the pattern and then implement that part. So this part's the data geology. This is the kind of, figuring out what it all looks like. This is the data mining part, which is usually in this capture data about an individual student, analyze the data against the geology or against the patterns that we've already established, and then select or decide on the action that's appropriate. And it's deciding on the action that's appropriate is also a challenging thing. And it's kind of like when you're sitting at a restaurant and you know the waiter's there and they're just serving you, trying to make your experience good, and they keep coming after you and saying, is everything okay? Is everything okay? Just go away. Leave me alone, I'm just trying to do this. You have to kind of balance when to intervene before. So if a learner's struggling, you don't want to jump in too quick, because struggling is a little bit of a good thing. But you don't want to leave it too long, because they either lose motivation, they quit, or you may have already identified, and I think Gov has said this before, we know what the students don't know before the students don't know what they don't know. We can look at this data and identify where they're struggling and what are the things that they don't know, or the knowledge gap that they don't know. What we're trying to do now is decide what to do, when to do it, how to do it. And that's going to be the second part of this study, which we're not there yet. We're really only in this understanding the data geology first. So to do that, of course, you need data. You need a lot of data, and we have a lot of data. So the data geology is this understanding the bigger formations. So when you see these kinds of patterns, then you do that. The learning analytics of the data mining is at the individual level, where actually then we've got the formations of what we're going to see. We're going to get individual data from these people. We need to know what to collect, how to collect it, and when to use it for. I'm using this example for the data geology. So I've got a rock here. Right? If you're looking for rocks, you can just go out in your backyard and find a rock, right? And they're good for paperweights, holding the door open, you know, throwing it around in glass houses, whatever you're using it for, right? So you've got these rocks. But if you want a rock that's actually going to be useful or interesting, you've got to understand the geology. So this rock happens to be a geode. So if you're looking for a geode, something that is going to really tell you something about something, then you don't want to just wander around in the West Desert out here looking for rocks. You really want to know what you're looking for, get the right kinds of rocks. So this last summer we went out in the West Desert and we're going to go geode, rock hounding, right? We're going to look for rocks. We happen to have a good friend of ours over in the geology department who's doing his master's, so we took him along. So we're driving out there along the Pony Express Trail looking for geodes. And as we're getting out there, there's a lot of interesting things to look for, a lot of interesting rock formations. And he said, see that? That's caused by this, this, and this. You won't find any geodes there. And we keep going. And he says, oh, see that range? On this side of it, you're not going to find any geodes, but I'll bet we'll find them on the other side of it. That's where we need to look for the geodes. And sure enough, we get over this round, we go around the back, and that's where we look. Once we got into the geode field that we're looking for, we're pushing all these rocks, and some rocks, they're useless. And other rocks, we say, is this a geode? And he's looking at it, yes, that is. No, that's not. That's just a hunk of rock. You know, and so he's actually helping us to understand that formation. First, we had to know where to look, what to get. Then we had to get the right rocks. And then, even though this is interesting, you got to cut it open and get inside it before you can actually use that data effectively, or the interesting part is actually deeper inside the data. That's what we're looking for. So once we've done that, so this is actually the biggest barrier, right? Getting the right data, finding the useful data, making sure that you can use it to inform your decision making. And there's many different levels of data that you can look at. So there's the keystroke level, what they're doing at each point. There's the answer level, which is usually where we go, or the course level, where we finish the test. So we usually have one question, answer the question, you get it right, we decide what to do. At the session level, it might be you got all of these correct, that's good. Or you might find information about the student. That's quite popular right now. Looking at their behavior, their emotion, what they're feeling, things like that. And other things about the characteristics. Sometimes they create a profile about the student, where they're taking it, what they are, and how they're supposed to be interacting through this. Learning preferences is one of the ones that was kind of a bust, but that's one way that people have looked at doing that. Most people don't use the keystroke level because they can't get to it. They can't cut the rock open and get down to it. But this particular kind of mine, it's a gold mine really, allows us to get to the keystroke level basically. So because this is a spreadsheet application, the nature of this particular course allows us to look at an individual cell and what the student does on a specific task, and looks at the iterations of how they're trying to create the formula or the function that is supposed to accomplish the task that they're required to do. That allows us to then look not just as when they got the right answer, but how they got to the right answer. Because you'd be surprised to know how many people get the right answer and don't know anything. And, well, maybe you don't. You're not surprised. Maybe you do that too, right? We get to the right answer, we say, yes, they got the right answer. But when you look at how they got to the right answer, or you ask them, why is that the right answer, you find out pretty quick that they don't know. They just got the right answer somehow. And so by able to look at what we call this activity trace data of how they're getting to the right answer, we can see the degree to which they understand, or if there is a knowledge gap in their getting there. You got a question?
Are they completing those assignments online? Is the spreadsheet online that they use?
Why don't you answer that?
So they download the spreadsheet from an online repository,
Okay.
and they complete it locally on their own machine.
Okay, and what do you use to collect that data?
So we just have a program that's running in Visual Basic for applications.
Okay.
The program already built into Excel.
Right.
that logs every change they make to a cell.
Okay.
And Visual Basic works really well with Excel, so that's kind of the right programming language to do. There's lots of different ways to program and things, but that one really works well with Excel. Another thing about Excel is that these structures, or this learning, is man-made to some degree. The structure of the functions and the formulas, what you put into the cell, the values that result from that function or that's all kind of a man-made thing, so it's very delineated. And we can, it's not like writing an essay where it could be anything and we don't know what's the right answer. We know what the right answer is, or the intended right answer is. And we can kind of track to see how they're getting to that right answer. So the nature of this course actually lends itself very well to data mining and to learning analytics to really understand where a learning gap might be in the learning that we have, right? And so we are actually trying to get, when we have access to the keystroke level or what they're doing in the iterations, and we're trying to look at the activity trace, how they're getting to the right answer as understanding the geology of this data. When students do this kind of thing, it's likely that they have this kind of problem or this kind of a knowledge gap or this kind of a misconception. And then we can say, well, what would an expert tutor do for that? And then we can try to program that in using all of the understanding that we have about the best ways to motivate students, when to jump in, when to leave it alone, and things like that. And that's how we're hopefully improving already a very successful program. You're in, what, 3 different universities? It's quite a popular...
7 universities now, and probably 10,000 students a semester.
that are using this system for that. Okay, and that's what I have to do, and then...
Not that.
Okay. Oh, you're gonna go.
10,000 here, there's probably more out there.
10,000 a year. Okay, so thanks for that introduction, Dr. Davies. What I want to do is I'd like to show a little bit of the data and show a little bit of some of the initial ideas that we have about what this data might have implications for in terms of learning and instruction. And specifically, again, our purpose of our research is to try to understand the data, identify some of the common errors that happen as students go through this worksheet, and then possibly program in some intervention or some instruction from that common set, so that as a new student goes down through this program, they might have extra instruction that comes to them specifically based on specific patterns that they're inputting to help them improve their learning, help their educational experience. So what we're going to try to do with this first phase, like Dr. Davies talked about, is really identify these common patterns of error. So what are students experiencing? So here's the data file. And I'd like to walk through this a little bit and drill down until we can actually look at an individual student in an individual cell and the actions and attempts they made in that individual cell. So just at a high level first, this is, I think it's the first 250 lines of this trace data. And so what this is it contains a submission ID, and each file that's uploaded to the server has a single submission ID. Now, one student can actually submit more than once, so it's not quite the student, but it's, for what we have right now, it's a good proxy for that. The next column is kind of a numbers column. So this is the number of actions taken in that submission. So in this particular assignment, there's actually 4 worksheets. There's a Boolean functions worksheet. Can you guys see that okay? An if function worksheet, and these are kind of separate sheets in the Excel document, right? So in the file, there's 4 worksheets. And these actions correspond to every action the student takes in that file. So for example, the first action the student took was they were in H11 cell in the Boolean functions worksheet, and this is the formula they typed in. It was an AND function. They typed that in, and open parentheses C11 equals yes, D11 equals quotes yes, close parentheses. And then this column is the display, the return that Excel makes in that cell, right? So when we put in a function, Excel performs the function and then displays the result. So this is the data And again, we've got, I'm just gonna scroll down here, we've got some coding here. This green coding means that there's some kind of syntax error. So that is a coding that automatically we can see visually something's wrong syntactically with this function.
So the false doesn't mean that's an incorrect answer. It just means that's what Excel put in
That's what's
the cell that
displayed.
it's supposed to.
Right.
So how do you know what the right answer is and what you're looking for?
Right, now that's an interesting question. The way we can find it in this worksheet is we can go to the last, generally most students get the problems right. So we can go to the last.
That one was right, by the way.
Action.
That first one was correct.
Very top. We can go to the last action for this cell and generally find, and count how many actions are similar for that function. And we know that that's the right cell.
Show them
That's the
what
right
it is.
answer.
The iterations of that. Is that what it is?
Is the green one an example of when they got it wrong? Because it just didn't work?
No, green is just syntactically incorrect.
Like a typing error?
But then like the next
Right.
one, they actually got it. Right. Like, what I'm saying is like that is showing that they made a misstep somehow, and then the next one is then corrected. So if you had multiple ones of those, then like that.
Right, and so we're gonna get into that, because I have some specific examples that show us some detail about that very thing, so. Way to look forward. So there's some interesting things we can do with this data. So right now, we've got a preliminary data set of about 344,000 actions. And it accounts for about, let's see, what was the number? 2,762 submissions. So 2,762 submissions that contain, actually the non-blanks are about 285,000 individual actions. Please.
And so submission is when they complete a worksheet and submit it for checking.
That's correct.
So this data that we're looking at here is for one assignment for one class
Right.
at a school.
So multiply that by,
That's a lot of data.
that's a lot of data.
It's a big class.
So this particular one is kind of drilling down. So what I've got in this chart is I've got a couple of different cells. In fact, the top 10 cells in the whole worksheet, and this worksheet's just one assignment, the top 10 actions by worksheet. So for example, H9, cell H9, H is the column, 9 is the row. In the worksheet lookup functions, there was almost 21,000 actions taken from these 2,700 submissions. And I bet you know what question that is.
I do.
And it would be interesting to correlate maybe where you spend your time as an instructor based on these, these number of actions.
So that's one of the toughest questions, that's what you're saying, right?
Oh, absolutely, and it was designed to be
Yeah.
the toughest question of the assignment.
In fact, it actually explicitly says that.
Yeah.
Mission accomplished.
It lived up to our expectations.
That's right. That's right. So let's see, another one, and there's four here that are over about 10,000 actions. You have lookup functions, H9. You have H18 in the if function worksheet. You have H11 in the Boolean functions worksheet. E18 in the if functions worksheet. And then there's a couple other high ones, and it kind of goes down from there. So this is one way to look at the data, where how many actions individuals are taking to try to get the right answer. So I'm going to zoom in here, and I'm
So
going to give you a
is
little
it fair to
context.
look at that and say that that's a measure of the difficulty of the item?
Yep. Somewhat.
I think so. I think that's a, I wouldn't say exactly, right? There's going to be some variation.
It's a measure of
in
the
that.
struggle.
Yeah, I think it's a measure of attempts, the
It's
number
an
of
effort,
attempts,
it's an effort.
some kind of effort measure.
Another thing that we noticed about a lookup function, it has a lot of prerequisite knowledge that you need to be able to answer that. So that's what makes it more difficult. Some of the other ones, like a Boolean function, it has far fewer kind of previous knowledge kind of things that need to be able to do that specific problem. So it's going to be less difficult just because of the nature of the problem in that. And so
Yeah.
it helps us also choose the ones that are kind of going to be most fruitful in our efforts to try to put some intelligence into the system.
Did you guys make any effort to track how much time was spent on average on those items?
It's there as well.
Okay.
Yeah, there's a timestamp for each action. And I don't have, I'm not sharing any timestamp, in this presentation. I've looked at that initially, and it's actually quite interesting as well, so.
Like you can
there's
tell when
definitely some
someone
work to do.
stops for 3 minutes and then comes back, to start doing it again, and how many times they kind of make these breaks. And then you can speculate what they're doing, going for a sandwich, taking a potty break, calling a friend for help, whatever.
Let's see, was there another question? Fred?
Yeah, I was just gonna say, you have to be very careful in interpreting this data, which it seems to me to be the real crux of this, because right away you said that's an indication that it's the most difficult question. What if that was not intended to be the most difficult question? Maybe it's vague, or maybe there are 3 answers and they can't determine it, or, they're not an infinite number, but quite a few numbers of reasons why that number is what it is. And so analyzing it seems to me to be,
That's why we're in the data geology phase.
yeah.
We really need to understand that. Or, you're right.
Yeah, that's a really good segue, but go ahead, another question?
Just on the top of that, what are you doing to better understand?
We're getting into that.
Okay. Right.
How to interpret it and what it
Right.
means and what the student, good, that's the right question to ask. I'm glad you asked that.
What does an individual question look like? I'm just trying to figure out.
Oh, good, that's exactly what I was next.
Okay.
So, these are asking great questions.
John, you got these guys
Way
so
to go.
excited.
This is great.
Tell me more.
Good question. So this is a sample worksheet. This is the Boolean function worksheet. I just stripped it out of their assignment. They have 4 worksheets. This is just one of them. Just to give you, this is just for our purposes here, just to understand a little of the context of the kind of the work that they're expected to do. So this particular problem is this cell H11. So if we go back here, this is H11 Boolean functions, okay? So this is the cell that we're talking about. Over 12,000, so it's top 3, the 3rd highest number of actions out of 2,700 submissions. And here's the cell right here. And the context is about an infield fly ball in baseball. And what they do is they have some data over here, and there's some rules that have to be true in order for an infield fly to occur. And so what the students are doing in this table, in this exercise, is they're building out these rules. So for example, the cell H11, there has to be a runner on first and a runner on second as a part of the infield fly call, right? That's kind of the first rule that they have to solve. And in order to solve that, what they're going to do is they're asked to use the AND function, and they're going to compare if there's a runner on first, yes, if it's true or false, because the AND function works on Boolean logic, true or false. So they're making a comparison here. So this is one of the correct answers. You could have C here, you could have C here, but this is what this is what the system's going to grade them on. C11 equals quotes yes. And what that does is that's comparing C11, cell C11, does it equal to text yes? And if yes, it goes to the next argument. D11, and I feel like I'm lecturing like Brother Ball does, and his, you can do this much better than I
Much
do.
better though.
No. The next argument is D11 equals, quote, text, yes, end quote. And the way the AND function works is if both arguments have to be true in order for the AND function to result in a positive, in a true result.
Which is the display that we're.
This is display. So in this case, C11 is equal to yes, that's true. D11 is equal to yes, no, it's not equal to yes, it's equal to no. Therefore, the result, the display here is false. And that's the correct answer for that cell. The next question then says, copy that cell down, and you're gonna check if there's a runner on first and second for each scenario. 30 scenarios here. Okay, but the H11 cell, remember that's the cell that has, what was it? 12,000 actions on it. So there's a lot of effort being put into this cell. So this is the context, right? So then let's go check out an example. So we go to the submission trace. So here's a submission. This is their first action in that submission, was this H11 cell. We have a timestamp for it, and this is the first thing they did. They put equals and. And the display was, has anybody seen that display before? Pound name. Which means?
That helps.
Nice, Excel is swearing.
That means it didn't complete the function.
Excel doesn't know what that is, right? It's not quite a function, it doesn't have the parentheses, that's kind of the error message for that input. And then, what's that, 2 minutes later, minute and a couple seconds later, they type in the same thing. Let's try it again, maybe it'll change. Same display. 4 minutes down, and again, we don't know, what happened during that 4 minutes. So between number 2 and 3, there was something that happened, right? Obviously, they went from and to, okay, let's try this. Equals and, open parentheses, C11, D11, comma, yes, close parentheses. So there, they have the and function, they have the C11, D11, which are the correct cells. They actually have the yes, and they close parentheses, and yet the display is same thing. Did you have a question?
And so these are submissions in the formula rather than as they type, they have this display until they complete their submission. In other words, they're hitting return or enter after each equals and so forth.
Right, exactly. They're seeing this display right after they hit enter when they type this in. Yep. Yep, good question. So another minute goes by and they try, well, let's try equals, because that's what they need to be. They need to equal yes. Okay, and another minute, almost a minute goes by and they say, okay, let's try yes for each one. So what's interesting about this data, right, is we can see where they started from and each action they're taking to try to figure this out. And if we look at this, there's this evolution of attempts and trying. So they tried with the true, they tried without the true, they tried different symbols, let's try greater than. Let's go no symbols, C11, D11. And that's the first different display they've had since they started, right? So in 20 minutes, they've managed 2 different displays with 8 different tries. And they keep going here. And that's one of the other interesting perspectives about this data is we get a sense for effort. We get a sense for they know it's not right yet. They have to keep going. So the next one, C11 equals yes, D11 plus, they're adding the cells equals yes, and they do that twice, about a minute apart, just to make sure that it's not right, I guess. And then 7 minutes go by. Here's an interesting one. So from 11 to 12, we know that 7 minutes go by, and all of a sudden, boom. Out of nowhere, the quotes come in. They hadn't used quotes before. They've got the equal sign in both of them, and the display is false. And they move on, and they don't do, there's not another input for that cell, for the whole worksheet. What's also interesting, so that's kind of an interesting series, right? So you have 12 attempts. They started at 8:30 roughly. We don't know if there was continuous 30 minutes, but it was 30 minutes between the first attempt and the last attempt. And we know what they did in between. We can see their attempts, we can see what they saw. And this is interesting because they're looking at that display, right? You can start to see almost a conversation going on between what the student's inputting and what the system's displaying to them.
Let me underscore something too.
Please.
They got the right answer. So when they handed this in, it was correct. So if we were grading this by hand, we would see row 13. We wouldn't see anything above that. We would give them full credit and think that they had mastered it from the beginning.
And there's no distinction between if it was their first attempt or their 13th attempt.
That's right.
And
That's a good point.
there's probably some indicators that they don't know a bunch of stuff that they need to know for this. They don't know about the difference between text and booleans. They don't know the difference between the cell references and the equal sign and less than. They've got a lot of kind of knowledge gaps there. In fact, this might be too many knowledge gaps. And sometimes if the knowledge gap is too big, you just say, you don't know anything, start again. Read this over, come on, you know.
So John, based on the time that they spent to finally get the right answer, once they had gotten the right answer, would you choose to give them another problem that was a close neighbor to the first one? And see if you could shrink that from 30 minutes to 1 minute?
That's another great question. In fact, this next line answers that very question. There's another cell in that spreadsheet where they're asked to do the AND function, and they did some other stuff in between here. I took out the middle stuff just for this example. They started on this particular cell at 9:07, and this is their first attempt. They had the quotes, they had the cell. Right after that, 20 seconds after, which is, you know, as long as it takes to type that in probably, they typed in the exact correctly formatted right answer, in fact. They had the AND function, and this particular cell, there was 3 cells they were checking, right? So you have the H11, the I11, and the J11 that have to be accounted for within that AND function, and they got it. So this is a very interesting point, which is their first try was 12 attempts. Their second time with this function was 2 attempts. Essentially, you could almost call it a 1 if this is just kind of a typing, you know, a typing try.
I'm hoping Rob and Tyler are taking this in. It's relevant to tomorrow.
How does it, so when you guys grade it, you're just grading on that final formula, is that correct?
Yeah, so the grading happens on the final state of the workbook, it's the final event.
But it's looking at the formulas and making sure that they match with.
Right. So, and yeah, there's quite a bit to it, we can talk offline if you're.
I just didn't know, like, you know, because they got the right answer both of those times in terms of the displayed false, but only one of those is actually the correct answer.
And the formal feedback that the student currently gets is that they got that correct and got full marks for it.
So how does a student know that they've gotten the right answer? Is it like really just trying to, I mean, because both of those are displaying the same thing, but they have different formulas. You know what I'm saying?
Yeah, for me personally, when I've done it, because they copy it down, I do a formula and then I copy it down and I can check to see, oh, did this formula work for all the other scenarios?
But I think the heart of the question is, why are these two different?
15 and 16.
These are answers to different questions. So line 13 is answering one task.
No, I'm talking about
Are you
23 and
talking about 13
24.
and 15?
I'm talking about 20,
Oh,
I'm talking about 15 and 16.
Oh,
Like,
you guys, your system knows, when it looks at the formula too, to see if it's correct. It's not just the display that came out
Yeah.
false.
I mean, currently, the system doesn't come while they're working on it and say, that's not right.
Right.
At the very end, they say, I'm done, submit, and that's when
So what's interesting to me too is that, you know, there's an interesting time element and action element that we could look at, right? I mean, here's 30 minutes of somebody learning, but you could also say that, you know, the last 7 minutes is where they really made that leap, where they came up to that leap. So again, kind of the purpose of our research is, can we identify common patterns of input that students are making and possibly intervene earlier in this process and say, hey, it looks like you might need some help with this particular function, with understanding between data types, between a Boolean type and a textual type. And if they had some intervention, maybe at the 5th or 6th try, I mean, if you look at this compared to the right answer, that's pretty close, right? We begin to identify the fundamental misunderstanding of where they're at on attempt number 6. If we intervene then we save them 20 minutes for this particular, possibly 20 minutes, possibly 6 other attempts, by helping them identify what they don't know that they need to know. In this case, it was the quotes, the difference between a Boolean value and a text value, for what they're comparing. So let me show you one more example and then we'll go. This is a different function, an OR function. This is the same Boolean. In this case, what they're looking for is a fly ball. So they're going to compare two columns. And if either one of these columns, this column or this column, is yes, if either one is yes, then the OR resolves to true. And that has to be true again to build this table out. So in this function, it's the OR function, and they're comparing whether either cell is true, resolves to true. This is an interesting one because here, they try E11 equals F11, and they get a false, which is an interesting, I'm not sure if that's an Excel quirk but there's only one value there. But what they do is they go down and they try different symbols between these two different cells. In fact, here is the same cell, and here's the range. You know, they're inputting the EF and the F11, the E11, the F11, the caret, the plus.
Let's
Yes,
raise
no.
E11 to F11 and see what happens.
Right, the power function there. Maybe E11 is less than F11. Right, this gives us some indication that they really don't, I mean, the fact that they're going through these different symbols says they do have some constructs of what cells should be in there, that they should both be inside the parentheses, inside the OR function, but how those two cells are related is a fundamental misunderstanding, that if we introduce some kind of instruction earlier on, it might help them learn better, learn faster.
John, what type of instruction is given? Is this based off like, lecture, or are they doing it like from notes, or?
Yeah, it's a great question. So integrated with the assignments is an electronic textbook
Okay.
that's also augmented with lectures that cover 100% of the text material as
Okay.
well. So most of the instruction for most of the students is in the form of watching these videos
Okay.
of similar type problems. We do have a classroom setting, but it's a flip classroom. So they come with questions, and the questions are answered, but there's very little lecture that happens.
There's also a little intelligent thing. Go back to the task. Can you turn it on and it just says,
I took it out of this one.
oh, okay. But
They
you
have
click
the-
on it, you say, give me some instruction, and it says, you're supposed to use the and function. Here's some explanation of the and function.
Okay.
So there is some kind of immediate
Yeah.
assistance there as well.
And is this, like, would this, like, that whole table, would that be kind of like one assignment, or a component of one assignment?
That's one, that's one assignment, right?
Okay.
Yeah, so this right here is approximately a fourth of a weekly assignment.
Okay.
So for this assignment, there's 3 other worksheets that are about this level of difficulty, about this much work. Maybe one of them's a little bit longer, but, yeah, so it's designed to take them between a half an hour to an hour to complete.
Unless they spend half an hour on the first question.
Half an hour on the first question, absolutely.
Well, that one there, go back to the submission trace. What, they've taken over a half hour just to get nothing. I mean, and it's clear that they've got the wrong answers on that OR function.
Yeah, the OR one ends up, they have a value display.
But it's wrong.
And that's where they stop. They don't return back to that cell.
So
So
you'd know that they got it wrong, but you don't, right now, we don't know why they got it wrong. We actually have to look at the data trace, and then we can start thinking about, they got this wrong because they don't understand Booleans, they don't understand the format of this problem, they don't understand Boolean logic. There's a lot of things that we could look at and say, we could intervene right now and help them out, rather than just say, you got it wrong, go back and read the material
Well,
again.
until they get feedback, they don't even know that, they may think they
Yeah.
have it right because they have a false there. And
Good,
so
that's right. That's why
we've
they
lost that
submitted it.
moment of immediate feedback because they're gonna check it off and say, oh, I got it right, and move on. And so that moment of reinforcing the correct practice has been missed, has been lost.
Yeah, and that's a good point. And so back to kind of maybe summarize, we have this first phase of identifying patterns and looking for common misconceptions. The second phase is then, based on these misconceptions, what is the most efficient, the best way, when to intervene, and how to intervene? Which opens up a whole nother dimension to this, which is, do we just intervene immediately when they get it wrong? Do we let them struggle? Do we intervene, and how do we intervene? Do we force them to go do instruction and then come back? Do we ask them if they want to participate in additional instruction? Do we offer suggestions on concepts that they don't understand? So how that intervention is done, it may be just as important, if not more important, than actual identifying the patterns and looking for these misconceptions. So hopefully that gives you a good sense for our research, the direction we're going in, and the possibilities with this kind of data. So thank you. Any other questions?